In this lecture, we will see the solution to problem 4.4, chapter 4, Griffith, third edition, Introduction to Quantum Mechanics. The given problem is use equation 4.27 and 4.28 and 4.32 to construct 𝑌00 and 𝑌21. Check that they are normalized and orthogonal. Here uh, we are dealing with associate Legendre polynomial, which is defined as PL m, which is a function of m, is equal to is defined as -1 power m into 1 minus x squared power m over 2 and d by dx power m and plx, where plx is a Legendre polynomial, which is defined as 1 over 2 power l into l factorial into uh, t by tx power l and multiplied uh, and x squared minus 1 power l. So using these two, we can construct the spherical harmonic. Y is called spherical harmonic. I have given a few lecture in detail in my theory class. So YLM, you can refer those lectures. YLM, which is a function of theta and pi, is equal to square root of 2l plus 1 over 4 pi into l minus m factorial plus l plus m factorial, uh, sorry, l minus m factorial divided by l plus m factorial, e power I m pi p l m cos theta. So using this three equation, we are going to find the spherical harmonic. First, we will see the Legendre polynomial for L equal to 0. By definition, the Legendre polynomial is 1 over 2 power L L prime t by tx L power L x squared minus 1 L. Now you take L is equal to 0. Everywhere L is equal to 0. 2 power 0, 1, 0 factorial also 1. This will become 1. So everything will become 1. So the P0x is equal to 1. So now from this you can find the associate Legendre, that is PLM, which is a function of x is equal to minus 1 power m 1 minus x squared power m over 2 uh, t by tx power m plx. This is by definition, just we have seen in the problem. Now L equal to 0, M also is equal to 0. So this will become 0 here. This power will become 0. This is 0 and this also 0 and PL, L also 0. So you will get anything power 0 is 1. So you will get all other term 1. Then it will be equal to P naught x. So this can be written as p naught power p naught x. But here we have seen that p naught x is equal to 1. That means p00, which is a function of x, is equal to p0x, which is equal to 1. So you keep it in your mind, then we will see the spherical harmonic. Now we will see the spherical harmonic, that is 𝑌 which is a function of theta and pi is equal to this one. Pi definition I have already explained. Now L equal to 0, M equal to 0, then what will happen? 𝑌00 is equal to, you substitute L and M0 here. So the first term is 1 over 4 pi. Second term L minus M 0. 0 factorial is 1. L plus M also 0. 0 factorial is 1. So the square root term will become square root 1 over 4 pi, and e power 0 also 1. So we will take this also 1. Then P00 cos theta. So let us say cos theta equal to x. This will become square root of 1 over 4 pi P00 x. Because sin P00 x is 1, then it will reduce to 2. Y00 is equal to 1 over square root of 4 pi. We have seen the spherical harmonic 𝑌00. Now we have to find 𝑌21, that is L equal to 2 and M equal to 1. So for which the Legendre polynomial PL of x is equal to pi definition, this one. Now you substitute 2 for L, because here L is 2 and M is 1. So this will become 2 square 2 factorial. This t by tx squared will become t by tx into t by tx, and x squared minus 1 L. Here L is 2. So x squared minus 1 whole square. Now you differentiate once. See here, 2 squared 4 and 2 factorial 2, it will become 8. So 1 over 8 t by tx, and you are differentiating this one. If you differentiate this x squared minus 1 whole square, then you will get 2 into x squared minus 1 into, if you take differentiation of x squared, you will get 2x. Then you take this 2 and 2 will become 4. You bring this 4 outside the bracket, because it's a number you can take out. So 4 divided by 8 will become 1 over 2. Then you multiply this by x. So you will get x cube minus x. So that's what we got here. Now you differentiate this x cube minus x. You will get 3x squared minus 1, because if, uh, differentiation of x with respect to x is 1. So you can write this as 3x squared over 2 minus 1 over 2. Now the next task is we have to find the associate Legendre, uh, that is PLM x is equal to minus 1 by definition. I have already explained this term. Now, for L you put 2 and M is 1. So this will become first term M minus 1 power 1 is minus 1. So I am keeping minus here. And this M is equal to 1. So this will become 1 by 2. That is 1 minus x squared power half, and this will become L is equal to 2, so this will become P2 x. So P2 P21 x is equal to minus 1 minus x squared power half into t by tx. We have seen already PL of x, where L equal to 2, that is P2 of x, just now we have seen, is equal to 3x squared over 2 minus half. So here you remember that there is a partial derivative. So if you differentiate this, the obviously the second term will go to 0. The first term, if you differentiate, you will get 2 into 3x. So 2 will get cancelled. You will get simply 3x. Now we have to find the spherical harmonic YLM. By definition, I have already explained the definition of YLM. Now we have to find Y21, that is L equal to 2 and M equal to 1. Substitute this in this expression. 2L plus 1, 2 plus 2 into 2, 4, 4 plus 1, 5, 5 divided by 4 pi, and in the numerator L minus M is 1 factorial, which is 1 divided by L plus M, 3 factorial. So I have written here 3 factorial. Here M is equal to 1, so this will become e power I pi. Then here next is PLM cos theta. P21 is because L equal to 2, M equal to 1 cos theta. You will get like this. Now our task is here 3 factorial is 6. 6 into 4 you will get 24. That's what I have written here. And now our task is to find P21 cos theta. We know we have seen just now P21 x is equal to minus 1 minus x squared power 1 over 2 3x. Now you replace x by cos theta, both left hand side and right hand side. So 1 minus cos squared theta power half and 3 times the cos theta. You know very well that 1 minus cos squared theta is equal to sin squared theta. Of course, there is power half. So this will become sine squared minus sine squared power of 3 cos theta. So if you take the square root of sine squared, you will get sine. So this will become sine theta. Of course, this is cos theta. And 3 I am breaking it in front. So this will become 3 sine theta cos theta. That's what I have written here. So I replaced P21 as 3 sine theta cos theta. So 3 I am bringing inside the square root, that will become 9. 9 into 5 divided by 24 5, and the remaining things are here. So we have seen this expression. Now I am writing 9 as 3 into 3 and 24 3 into 8. Then 3 3 will get cancelled. So in the numerator 3 times 5 you will get 15, and denominator it is 8 5, and of course there is a negative sign, and e power I pi sin theta cos theta. This is the harmonic 𝑌21, harmonic 𝑌21. Now our next task is we have to find this whether that is we have to check whether these two spherical harmonics are normalized. First you take the spherical harmonic 𝑌00. Then if you normalize it, you will get double integral modular square of this one, that is 𝑌00 sine theta d theta and d pi, because this spherical harmonic is function of theta and pi. So we are taking integral. You can separate this integral into two parts. One is integral between 0 to pi sine theta d theta, and 0 to 2 pi d pi. So now you can take this first integral. First integral value is 2, and second integral value is 2 pi. If you multiply this, you will get 4 pi. This 4 pi will get cancelled with this 4 pi. So it will be equal to 1. So this spherical harmonic is normalized. Then we will see the next harmonic, that is 𝑌21, which is a function of theta and pi. is equal to minus square root of 15 over 8 pi e power I pi sin theta cos theta. Now you take, as done in the previous case, you take the modular square of this one. So if you take modulus square of this one, you will get 15 divided by 18, this one. Because you are taking modulus square, so this negative sign will go away. If you take modulus square of e power I pi, then its complex conjugate is e power minus I pi. So if you multiply both, you will get 1. So the only term remaining is sine square theta and cos square theta. So this will become sine square and sine square theta cos square theta. Already there is a sine square theta here. So that sine square theta t theta. Of course, I am separating this pi. So t pi I am integrating over 0 to 2 pi. So if I integrate this between 0 to 2 pi, as I got here, this is applying the maximum limit and the minimum limit. Naturally, this will be 2 pi. So this 2 pi will get cancelled with this 8 pi and it will become 4 in the denominator. So now we got 15 over 4 integral between 0 to pi sine squared theta cos squared theta sine theta t theta. So now you can simplify this sine square theta is nothing but 1 minus cos square theta, and here 1 cos square theta. Of course, you have this sine theta, t theta. Now you keep u, which is equal to cos theta. And then what is tu? Tu is equal to minus sine theta d theta. So that minus I brought here. That is, instead of right hand side, I kept left hand side. Both are same. So here this sine theta t theta is equal to minus tu. Remember that. This I am replacing. This cos square theta is u squared. This 1 minus, then it will become 1 minus u squared. Here also this cos square theta will become u squared. This sin theta d theta is equal to minus tu. So I am replacing this minus tu. Now we will simplify it further. And also I am changing the limit. Remember that I have changed the limit. When theta equal to 0, cos 0, 1. So our lower limit is 1. Upper limit cos pi is minus 1. You remember that. Now you are integrating between uh, plus 1 to minus 1. That also you have to keep it in your mind. So we got this expression minus 15 over 4 integral between 1 to minus 1 1 minus u squared multiplied by u squared tu. Now is a symmetrical limit, so we can change it into 2 times 1 to 0. So I am replacing minus 1 to 0 and multiplying by 2, because this is equal to, this integral is equal to 2 times this integral. There is a negative sign, you remember that negative sign, and I brought this u squared inside. So first term will become u squared, next term will be minus u power 4, because I am multiplying these two. Now I am changing the limit from 1 to 0 to 0 to 1. So this negative sign will go away. So now you integrate it and apply the limit. So first term will become u power 3 over 3 minus u power 5 over 5. Apply the limit 0 to 1. So upper limit is 1, lower limit is 0. First term will become 1 over 3. The next term will become 1 over 5. So the terms inside the bracket can be written as 5 minus 3 divided by 15. So this 5 minus 3 is equal to 2. Naturally, this 2 will get cancelled. Similarly, you have 15 here and 15 here. Both will get cancelled. So you will get 1. So this second harmonic also, spherical harmonic also normalized. Our next task is to prove that these two spherical harmonics are orthogonal. So you do the double integral 𝑌00 𝑌21 sine theta t theta t pi must be equal to 0. We have seen 𝑌00 is equal to 1 over square root of 4 pi, and 𝑌21 is equal to minus square root of 15 divided by 8 pi e power I pi sin theta cos theta. So I am substituting this. See, instead in the place of y00, I am taking this 1 over square root of 4 pi. So since it's a constant, I am taking out. In the next case, y21, I am taking this one. So since this square root term, including this minus, is a constant, I am taking out. So minus square root of 15 over 8 pi, and this integral will become e power I pi sin theta cos theta. Of course, there is already one sin theta t theta t pi. So now you separate this integral into two parts. Here you can see sin theta, sin theta. You will get sin square theta, and this is cos theta, t theta. This integral limit is 0 to 5. So, and the next integral is 0 to 2 pi e power minus I pi t pi. If you integrate e power minus I pi, then you will get e power I pi divided by I. So if you apply the limit, if you apply the uh, upper limit, you will get e power 2 pi is 1, and e power minus e power 0 also 1. 1 minus 1, you will get 0. That is second integral will become 0. So you need not worry about the first integral. After all, it is a multiplication factor. So this anything multiplied by 0 is equal to 0. This also will become 0, but it's little bit lengthy integral. But you can take it granted. Anyway, it is going to be 0. So these two spherical harmonics are orthogonal in nature. Thank you very much for watching my video and supporting me regularly.